Polytropic process. Now the concept of polytropic process is very simple. See, in case of adiabatic process, the equation you remember, if you recall, then the equation was simple, that is PV raised to gamma is equal to constant. That was the generalized equation for adiabatic process. Okay, but in case of polytropic process, your equation become this, that is PV raised to n is equal to constant. So what is the difference? The difference is very simple, that in case of adiabatic process, your gamma is fixed. Okay, that is for air, let's say gamma is 1.4. Okay, so the gamma value is fixed, adiabatic index is fixed. But if you have value other than this gamma, then it will be called as polytropic process. Okay, so for polytropic process, we can derive the different quantities just like the adiabatic process. So let's start that. So work done of polytropic process. So as you can recall, it is the just same as the adiabatic process, that is PV raised to n is equal to constant, equation number 1. Now if we make P as the subject, then C divided by V raised to n. Now in the case of work done equation, if you integrate P dV, then further after doing the integration, it is just like the adiabatic process. So your final equation will be like this, that is W is equal to P1 V1 minus P2 V2 divided by n minus 1. Only the difference is here instead of gamma you have now n. Okay, further W is equal to what? So if you substitute the value of PV, then you can write mR T1 minus T2 divided by n minus 1. Okay, further we can substitute the value of R and gamma. So if you do so, then the work done will be mCV T1 minus T2. Okay, so you can correlate this particular process or steps with adiabatic process. Further, relation between PVT, that is also same. Okay, but instead of gamma you will write now n. Okay, further change in internal energy, so delta U is equal to mCV T2 minus T1. Heat transfer during the process, that will be Q is equal to delta U plus W. Remember students, in case of polytropic process, heat transfer is not 0, because in case of adiabatic it was 0. That itself was called as adiabatic process. But in case of polytropic process, the heat transfer might not be 0. So Q is equal to delta U plus W, wherein you will substitute the value of delta U and you will substitute the value of W. Okay, now we will just try to solve this in further expansion. Okay, now CV we know that is equal to R upon gamma minus 1, right? So what we can do is we can substitute the value of CV. So what you can write is, here you can see, here we have this value of CV. So instead of this CV, we can write R upon gamma minus 1, that is written in the next step. So as you can see, mR T2 minus T1 upon gamma minus 1 plus P1 V1 minus P2 V2 divided by n minus. Now what we can do is we can just open this bracket, and also we can substitute the value of mR_T2 as P2V2 and the value of mR_T1 as P1V1. So that is how this particular equation is written. Okay, instead of mR_T2 I have written P2V2, instead of mR_T1 I have written P1V1. Okay, now what we can do is we can rearrange the terms. Okay, so two terms are rearranged. Now P1V1 minus P2V2 divided by n minus 1 minus P1V1 minus P2V2 divided by gamma minus 1. Simple. This minus sign is taken on the front side. Okay, and this particular first term is written on the second. Okay, so that is how you can observe this. Further, if we bring, or if we take P1V1 minus P2V2 common, then what we are left with is 1 upon n minus 1 minus 1 upon gamma minus 1. You can take LCM of this thing. So LCM of this thing is written over here. Further, if we write, then P1V1 minus P2V2 divided by n minus 1 into gamma minus n upon gamma minus 1. If you observe closely and carefully, then this is nothing but the work done during polytropic process. So whenever you are writing the work done during polytropic process, then it is nothing but heat transfer is equal to work done during polytropic process into this gamma minus n upon gamma minus 1. That is my next step. Okay, so that is how you can write the heat transfer. Remember student, this is very important funda in case of numericals. Okay, so you have to remember this particular relation, that heat transfer during polytropic process is what? It is nothing but the work done during the polytropic process into this particular bracket, that is gamma minus n upon gamma. Now change in enthalpy. Change in enthalpy delta H is equal to mCp T2 minus. Okay, now index of compression or expansion, that is n. So what is the significance of n? How can you find out n? So we know that P1 V1 is raised to n is equal to P2 V2 raised to n, right? So if you rearrange the term, then P1 by P2 is equal to V2 by V1 raised to n. Now if we take logarithm on the both the side, then ln P1 by P2 is equal to ln V2 by V1 raised to n. So this n will come on the front side as per the rule. So ln P1 by P2 is equal to n ln V2 by V1. Now if we make n as the subject, then what we can write, ln n is equal to ln P1 by P2 divided by ln V2 by 1. Okay, I hope it is clear to you. So you can find out index of compression or expansion, or you can also say this is polytropic index. So you can find out this index using this particular equation in numerical. Okay, so pressure should be given and volume should be given, so you can find out the value of n, right? I hope it is clear up to this point. Now we will see numerical regarding the same. Let's understand this. A tank contains 3 meter cube of air at 25 bar absolute pressure. This air is cooled until its pressure and temperature decrease to 15 bar and 21 degrees Celsius respectively. Determine the change in internal energy, change in enthalpy and heat transfer. Take Cp as 1.005 kJ per kg Kelvin and Cv as 0.718 kJ per kg Kelvin for air. Okay, so the problem is given like this, in which a tank is there and the tank contains 3 meter cube of air, okay, and 25 bar is absolute pressure initially. Now what happened? The air is cooled and the pressure and temperature is decreased. Okay, so that is the thing. Now first of all, identify which process is given, whether it is constant pressure process, constant volume process, constant temperature process, adiabatic process, polytropic process. Which process is given? You have to think that with the help of given data. Okay, so here you can easily identify that the pressure is not changed and the pressure is changed, so you can easily conclude that it is a constant volume process, because it is temperature is also changed and pressure is also changed, so only volume is constant. So the process given is constant volume process. Now volume is constant, that is 3 meter cube. Initial pressure is 25 bar, final pressure is 15 bar, final temperature is given 21 degrees Celsius. Convert it into Kelvin. Always convert the temperatures in Kelvin when you are dealing with thermodynamics. Okay, 21 degrees Celsius converted into Kelvin, 294 Kelvin. Next, constant volume process. So we know the equation, that is pressure is proportional to temperature. So P1 by P2 is equal to T1 by T2. Make T1 as the subject. Okay, so we can find out the initial temperature, that is 490 Kelvin. Now what we are supposed to find out? We are supposed to find out the change in internal energy, that is delta U. Okay, second thing is what? Change in enthalpy, that is delta H, and the third one is heat transfer Q. Delta U, delta H and heat transfer Q. So you should remember the values or equation of these three quantities. Okay, you might be remembering that for constant volume process the work done will be 0, so keep that in mind. Now mass of air in the tank can be calculated using the characteristic gas equation, okay, because mass is not given, so we can calculate this. So PV is equal to mRT, right? So for that we have to make m as the subject, okay, but before that we have to find out this R. Okay, so what is R? So R is nothing but difference between Cp and Cv. Cp and Cv is given, right? So you make these values over here. If you recall, then this here is already derived, right? So it is very important result. So for air, the characteristic gas constant value is 0.287 kilojoule per kg Kelvin. Okay, now we substitute the value of R in this particular equation and we make M as a subject. So the mass of air will be 53.33 kg, right? Further, change in enthalpy. So change in enthalpy is equal to what? So H2 minus H1. So change in enthalpy will be M Cp T2 minus T1. So mass is given to us, or we have found out the mass. Cp, that is specific heat, is given to us. T2, that is known to us. T1, that is known to us. So that is the final answer is minus 10,504.9 kilojoule change in enthalpy. Now negative sign indicates what? Negative sign indicates that this much enthalpy has decreased by decreasing the pressure and temperature of the air. Okay. Next, change in internal energy. So internal energy change U2 minus U1 can be written as M CV T2 minus T1. Okay, so here the value of mass is already known to us, value of Cv is already known to us, and temperatures are already known to us. So what we can find out is the value of change in the energy as minus 7505 kilojoule. Okay, here also the negative sign indicates what, student? Negative sign indicates that the air is losing its internal energy, or the internal energy of air is decreased during the process. Okay, always remember negative sign indicates what? Decrease in the particular property, and positive means what? Increase in the particular property. That is very much common sense question, right? Now what we are left with, delta H is found out, delta U is found out. Now heat transfer. So how can we find out heat transfer? So heat transfer is nothing but Q is equal to delta U plus W according to first law. But we know that W is equal to 0 because constant volume process. I already told you earlier that work done during this process will be 0. So W is equal to 0. So now what we are left with, Q is equal to delta U. So whatever your change in internal energy will be there, that will be exactly same as the heat transfer during that particular process. So heat transfer during this particular process is what? Minus 7505 kilojoule. That means what, student? Let's understand this problem in a correct manner. The understanding is very simple, that initially your temperature was 490 Kelvin for the air. Initially the temperature was 490 Kelvin, and final temperature is what? 21 degrees Celsius. That means what? 294 Kelvin. Okay, so you have decreased the temperature. Now you might be having questions, sir, how have you written 490 Kelvin? So in the previous page we have already found out the value of T1, that is 490 Kelvin. That's how I have written this. Okay, so that means you are cooling the air inside the tank. So if you are cooling the air inside the tank, then think logically that during the cooling process the internal energy will decrease and enthalpy will also decrease, because enthalpy is what? Enthalpy is nothing but the representation of energy. Okay, so it's a kind of energy. So your energy will decrease when you will decrease the temperature. That's why you can appreciate that these values are negative, and this is how you can apply your understanding to the numerical. Okay, so today we will keep up to this point. Thank you.